Whenever someone creates an instance of our lottery contract now, we're going to take their address and assign it to the manager variable. So we'll always know who the owner of any given lottery contract is. That pretty much finishes up our first variable here, the manager variable. Now we can move on to our next variable, which is the players variable. And this is supposed to be an array of addresses for each person who has entered our lottery. Before we just go ahead and create this variable, it's really important that we get an idea of how arrays work with Solidity. We spoke a little bit ago about some of the different value types or basic types that are available to us in Solidity. We spoke about strings, booleans, and so on. You get all these right here. We're now going to have a very similar discussion about some of the different reference types that are available to us. So an array in Solidity is an example of a reference type. As we start talking about these reference types, we're going to do a quick little divergence, or we're going to put our lottery contract on hold for just a little bit. So we're definitely going to come back to this, but this idea of reference types is really important in Solidity. And it's also where there are a lot of gotchas and tiny little issues that come up. So I want to make sure that we have plenty of time to discuss all these reference types. All right, so let's dive into it. Here's a listing of all the different reference types that we have available in Solidity. A lot of these are really going to look quite familiar, especially if you have experience with JavaScript in the past. However, like I just said, there's a lot of tiny little gotchas around them, and those gotchas are what make them a little more challenging. So let's go through each of these one at a time. The first type that we have available as a reference type is a fixed array. A fixed array means that we have an array or a collection of different values, and that array can never change in length. If you're coming from the world of JavaScript, this might seem quite surprising, because in JavaScript we can create an array and always resize it on the fly. So there's absolutely no issue in JavaScript with removing elements entirely or adding new ones, essentially changing the length of the array. That's totally a-okay in JavaScript. But for a fixed array in Solidity, no changing the length. It's always going to be a fixed length. Note that every single element that goes into an array in Solidity must always be of the same type. Over on the right-hand side, we can see two examples of fixed length arrays. Note that the little arrow that I put in here is not a Solidity operator or anything like that. I only mean to say that an example of an integer fixed length array of length 3 would be 1, 2, 3. So the 3 here represents the number of elements that can exist inside this array. And then you can see over here, yep, there's definitely 3 integers inside there. And then similar over here, we can have a Boolean type array that has at most or at least 2 elements inside of it, and maybe those are like true and false inside there. Very similar to fixed arrays, we have dynamic arrays. So as you might guess, these are arrays that can change in size. They can grow or shrink in length over time. Dynamic arrays are going to behave much more similarly to how you are used to using arrays if you're coming from the world of JavaScript. So we can add in elements, we can remove them, whatever we want to do. We can really hack these things up. Whenever we declare a dynamic array, we don't place a little number inside those square brackets. So the presence of a number indicates how many elements an array should have. If we put a number in there, that means this is the number of elements. If we leave it blank, that automatically means that we are creating a dynamic array that can grow or shrink in length. For our project, the lottery contract, chances are we're going to end up using a dynamic array because we want to allow as many people as we wish to enter into the lottery. If we had added in some arbitrary requirement of our lottery contract, if we had said that at most only 5 people can enter into it, then that would have been a good example of where we would use a fixed array. But for us, we want any number of people to be able to enter, so I think we're going to end up using a dynamic array. Now I want to speak a little bit more about arrays very quickly. So we're going to speak about mappings and structs in the next video, but first I want to show you some examples of using an array in action. So this is going to be an example that focuses around mostly dynamic arrays, because personally that's what I expect you're going to be making use of in your own projects. So I took the liberty of writing up a little code snippet here, and the goal of this code snippet is really just to give you an idea of how we work with arrays. For the most part, they're going to feel very familiar. So in this example right here, you can see that I created a contract called test. My test contract has a dynamic array of unsigned integers called myArray. Sorry, I know the scrolling is jumping around here. It's because I'm so zoomed in, but I want to make sure that it's easily legible. Now inside the constructor function for this contract, you'll see that my array has a method called push. Push behaves just the same way as it does in JavaScript, so we can push in new elements that cause the array to grow in length. So when we push in a value of 1 right here, that makes our array have length 1, and the first element contains the value of 1. If we push in 10, that means that the second element will have the value 10, and you get the idea for 30. Third element, and it has a value of 30. We can retrieve the length of an array by calling .length or referencing the .length property on it. Again, very much like JavaScript, it should feel quite familiar. And then if we want to, we can access individual elements within an array by using the very familiar square bracket notation. And just like JavaScript and many other languages, Solidity arrays are 0 indexed. So to get the first element out of an array, we use the square braces, or square brackets, whatever you want to call them, and we would pass in 0, or reference 0 right there. Now there's one very interesting thing about arrays in Solidity that I want to mention right now, and I'm going to mention this many times throughout the course, because this is something that many people find quite surprising. I want you to recall that whenever we mark a variable up here as public, we automatically get a new function created for us that allows us to access this variable. Remember, we saw that in action back on the inbox contract. Because we marked our message variable as being public, we automatically got a function called message. Now, something very similar exists around arrays in Solidity. However, its behavior is slightly different than what you might expect. So I'm going to deploy this contract right here, and I want you to see what happens when we try to access my array. So I'm going to click create. That's going to create my contract. Here's my contract right here. If I want to, I can get the first element. So that retrieves 1 because I pushed in 1 inside the constructor right there. I can get the array length, which is of length 3. And now here is the automatically synthesized function to get or issue a call to the variable myArray. So whenever we have an array in Solidity, the function that gets generated does not return the entire array. That's the important thing. That's the part that's a little surprising. Instead, the function that is generated always is going to accept one argument, and that is the index of the element that we want to retrieve in the array. So back when we were working with message, or the inbox contract, when we wanted to get message, we just clicked the message button, and that gave us the entire contents of the message variable, like the entire string. But whenever we are working with an array, we have to ask for individual elements. So I can say, like, give me the element at index 0, and that will give me 1. I can ask for the element at index 1, and that will give me 10, because that's the second value I pushed in. And I can ask for the element at index 2, and that will give me 30, because that was the third value that I pushed in. So that's just something to be aware of. Now, if you want to, you can always write a function that will return the entire array, like everything inside of it in its entirety. And I can very quickly show you an example of that. By the way, I know I'm going through this stuff very quick, but this is just your first taste of arrays to give you a sense of how they are similar or different from arrays in other languages. We're going to be repeating all these same limitations and stuff over time, so don't worry if it feels like we're going too quickly. I just really want you right now to be aware that some things are similar and some things are different. Anyways, back to this, let me give you a quick example of retrieving an entire array. So we could say, get my array. This will be public and view, and I'm going to say that it returns a type of uint, and it's a dynamic array. So I'll say uint and place my square brackets like so. And then inside of here, I can simply say return my array. All right, now I'm going to redeploy my contract. If I can scroll down, I think that I already deleted the other one, so I'll just click create. Yeah, there we go. All right, so now I've got get my array function right here. And if I click it, I get back all three values, 1, 10, and 30. So we can kind of circumvent this restriction right here, or I shouldn't even call this a restriction, but we can kind of get around the fact that the generated getter returns only one value at a time by writing our own function. However, even with this, there are some little gotchas that are going to come up over time. If we were working with simple values like uints or booleans or whatnot, we can return the entire array. But if we are working with more complex values like an array of arrays or an array of structs, which is another value that we'll discuss, then we can't quite use this technique so much. But again, that's something that we'll come back to and discuss in due time. All right, so at this point, we've spoken about some of the basics around arrays. At this point, I really just want you to have an idea that arrays exist. They can be dynamic in length or fixed in length. And in general, they mostly work in the same way that JavaScript arrays do. So let's pause right here. We're going to come back in the next video, and we're going to discuss some of the other types that are available to us in Solidity.